Volume and surface area of cylinders and cones. A cylinder is any three-dimensional object that has a circle base. And so you might want to think about an ice cream tub. So if you wanted to get a Ben & Jerry's ice cream tub that comes in a cylindrical shape, so that could be an example of that. When we're thinking cones, sticking with that theme of ice cream, think of an ice cream cone, right? So it has the circle top, and then it tapers down to a point at the bottom. So we're going to determine the surface area and volume of a cylinder first, and then we're going to look at how that compares with our surface area and volume for a cone. So when you're calculating the surface area and volume of a cylinder, you need to know two dimensions: the radius of your cylinder and the height of your cylinder. So for example number 1, the radius is given to us as 10 centimeters, and the height is given to us as 30. And it doesn't matter which calculation you do first, but because it says volume first, we're going to calculate the volume. So the volume is pi r squared times height. We can substitute in the value of 3.14 in for our value of pi. The radius is 10 squared, and then our height is 30. So following order of operations, it tells us that we need to do our exponents first. So 10 squared is 100, 10 times 10. And then the last thing we want to do is multiply these three numbers together. 3.14 times 100 times 30 gives us 9,420. So we didn't, even though the question says round to 2 decimal places, we don't actually need to do that for ours. So now what we need to do is include our units. Our units are centimeters, and because this is volume, we need to cube these units, so centimeters cubed. The next calculation we have to do is the surface area. The surface area of a cylinder can be found by taking 2 times pi r squared plus 2 times pi times r times h. So I've taken the area of 2 circles and the area of this would be a rectangle if I was to fold it all the way around or unfold it. So again, I'm using my radius of 10 centimeters and my height of 30, and I'm going to substitute those numbers in for my variables. So I'm going to take 2 times 3.14 times 10 squared plus 2 times 3.14 times 10 times 30. I can multiply my 2 and my 3.14 together first to give us 6.28, and then I can multiply it by 100, which is 10 squared, and then I can multiply all 4 of those numbers together. So 2 times 3.14 times 10 times 30. And that gives us an answer of 1,884. The next thing I want to do is multiply my 6.28 by 100. That gives me 628 plus 1,884 for a final surface area of 2,512, and my units are centimeters squared for surface area. Now when I'm looking at a cone, I want to again think about how I calculate my surface area and my volume. So the surface area is the area of a circle, so pi r squared, and then we have our pi times our r times our slant height. So the slant height is this curved, or this hypotenuse if I was to draw a right angle triangle inside of my cone. So this is my S. My slant height is this measurement right there. My volume can be found by taking the area of my circle, so that's the pi r squared, times the height of the cone, which is 17 in this case, and then dividing it by 3. If we were in class, we could actually do a demonstration of calculating the volume, and if we fill up a cone and a cylinder that have the same base, we could find that it would take 3 cones to fill up 1 cylinder, and that's why when we're calculating the volume of a cone, we're dividing by 3, because a cone is 1/3 of a cylinder when they have the same base. So we're going to calculate the volume and surface area of this cone, and we're going to round our final answers to 2 decimal places. So the volume is pi times r squared times h divided by 3. The radius of my cone is 9. The height of my cone is 17. And I'm going to substitute in 3.14 for my value of pi. So 3.14 times 9 squared times 17 divided by 3. Following order of operations, I must do my exponent first. So 9 squared is 81. And then divide by 3. You can do this in one step. You don't need to show multiple steps for here. So you could do this all in your calculator. So 3.14 times 81 times 17, that equals 4,323.78, and then divide that by 3. So if you wanted to do it in one step in your calculator, you can. If you wanted to simplify your numerator and then divide by 3, you can do that as well. So your final answer will be 1,441.26. So you can go right from this third step to the last step, or you can show this intermediate step. And my units are centimeters, and because it's volume, it's centimeters cubed. So in order to use the formula for surface area, I need to know the slant height. So we talked about that, what the slant height is. But in order to find the slant height, we need to use Pythagorean theorem. So let's do the calculations just down here. So Pythagorean theorem says a squared plus b squared is equal to c squared. And in this case, our 9 will be our b, our h, or our height, will be our a, and our s is our hypotenuse, so that's our c, because it's right across from your right angle. So my height is 17 squared, my base is 9 squared, and my hypotenuse for Pythagorean theorem is our s squared. So you can keep that as c, or you can substitute in s. 17 squared is 289, and 9 squared is 81. That is equal to s squared. 289 plus 81 is 370. That's still equal to s squared. To go from s squared to s, you need to take the square root of 370, because the opposite of squaring a number is square rooting a number. And this gives us a slant height of approximately 19.2 centimeters. So now that I've determined what my slant height is, then I can use that in my formula for surface area. So if I come back up, the surface area is this formula right here. So surface area is equal to pi r squared plus pi times r times s. I'm going to use 3.14. My radius is 9 squared plus 3.14 again times 9 times my slant height, which was 19.2. So following BEDMAS, 3.14 times 81, and I can multiply these three values together. 3.14 times 9 times 19.2 gives us 542.592. 3.14 times 81 gives us 254.34. I'm going to add that to 542.592. And to give us a final answer of 796.93, because I'm only keeping 2 decimal places in my final answer, and my units are centimeters squared. So now that I've looked at an example of finding the surface area and volume of both a cylinder or a cone, I'm going to take that information and apply it to some word problems. So I'm going to start with example number 3 that looks at 3 tennis balls that are packaged in a cylindrical container. Each tennis ball has a diameter of 3 inches, and we're going to calculate the minimum volume of the container. So I'm going to start by drawing a tennis ball package. So if you remember, tennis balls are stacked one on top of each other, and then we're going to draw our cylindrical shape directly around it. So there's not a lot of movement in our container once we put our tennis balls inside. We do know that a tennis ball has a diameter of 3 inches. So the diameter of my circle up top is 3 inches. And if the diameter of the circle is 3 inches, that means the height of my cylindrical container is going to be 9 inches, because I'm going to have 3 inches for the first tennis ball, 3 inches for the second tennis ball, and 3 inches for the third tennis ball. 3 plus 3 plus 3 is 9 inches. So once I have those measurements, then I can look at the volume of my cylinder. So the volume of a cylinder is pi r squared, so the area of the base, times the height. I know the diameter. So the diameter of my shape is 3 inches. So the radius is 3 divided by 2. Because the radius is half of a diameter, or 1.5 inches. So now I'm going to use that information to substitute in the numbers for my variables. So 3.14 times 1.5 squared times my height of 9. I must do my exponents first. So 1.5 squared is 2.25. Times 9, and I'm going to multiply those 3 values together to give me a final answer of 63, and I'm going to round this to 1 decimal place, so to the nearest tenth, so 63.6, and my units will be inches cubed. So every word problem needs a therefore statement. Therefore, the minimum volume of the container is 63.6 inches cubed. And the last example we're going to look at involves a cone. So a cone-shaped cup has a height of 4 centimeters and a radius of 3 centimeters. So I'm going to start by drawing my picture. It has a height of 4 centimeters, so the height is 4 centimeters, and a radius of 3 centimeters. We're going to, first of all, find the slant height of the cup. So that is this area right here. So if I wanted to redraw just a portion of this cup so that I can see the Pythagorean theorem, so the right angle triangle that I need. So this dimension right here is going to be my 3 centimeters. My height is my 4 centimeters, and I need to calculate the S. So the slant height, so that's right across from your hypotenuse, or your right angle, which is your hypotenuse. So I'm going to figure this out using Pythagorean theorem. That says a squared plus b squared is equal to c squared. I'm going to use 3 as my b, 4 as my a, and s as my c. Your hypotenuse will always be your c. So I'm going to have 4 squared plus 3 squared is equal to s squared, or 16 plus 9 is equal to s squared. 16 plus 9 is 25 equals s squared. The square root of 25 is equal to s, so s has a value of 5 centimeters. So now that I have the slant height, then I can figure out the surface area of the cone, because I want to know how much paper is required to make 100 cups, but first I need to figure out how much paper is required to make 1 cup. So if I refer back to my formula sheet, or up the top of my page, the surface area of a cone is pi r squared plus pi rs. So I'm going to use that formula down here for example 4. So the surface area is pi r squared plus pi rs. So 3.14 times 3, that's my radius, squared, plus 3.14 times 3 times 5, that's my slant height. So I have 3.14 times 9 plus, and then I can calculate this, 3.14 times 3 times 5 gives us 47.1. 3.14 times 9 gives us 28.26. I'm going to add that to 47.1 to give us a final answer of 1,331.0. I'm not gonna, if I take a look at this, it doesn't, if I round this to 1 decimal place, it's just 0.0, and then my units are centimeters squared. So this is the how much surface area or how much paper is required to make 1 cup. So in order to find out how much is required to make 100 cups, I want to take the value of my surface area for 1, and I'm going to times it by 100. So this gives me a total surface area of 133,100 centimeters squared. So our final therefore statement that will be, therefore, 133,100 centimeters squared is required of paper. Sorry, I'm going to change that. Of paper is required to make 100 cups. Now, I think I've made a mistake. So I wanted to add this. I think I may have multiplied that because that looks very large. So 28.26 plus 47.1 is equal to 75.36. That's a much better number. So my apologies for that. So this should be 75.36, which means that this will change. So we should have 75.36 times 100. which gives us 7,536 centimeters squared. So I need to change my therefore statement as well. So therefore, 7,536 centimeters squared of paper is required to make 100 cups.